All right, I want to welcome everybody to the Astrix Digital Transformation Podcast series. These are interviews with thought leaders and experts on developing a successful digital-first strategy for transforming life science R&D. My name is Kevin Miller. I'm going to be your host for today's podcast, and thank you very much for listening in. Before we get into the topic, of course, I want to introduce our speaker for today. Our topic is going to be next level digital transformation, which is reimagining what is possible. To get us started on a very timely topic, I'd like to introduce our speaker, Dave Dorset, who's a principal software architect with Astrix. I've done a lot of programs with Dave in webinars, so we're thrilled to have him today. He is a very experienced leader in the R&D field, especially R&D informatics. He's led global digital transformation initiatives that drive critical data science strategies to improve overall life science R&D. From early research through product development, scale up, manufacturing. Dave, thanks so much for joining us today. If you want to take a few moments and tell us a little bit more about yourself and what you're going to do today.
Sure. Well, thank you very much for having me. I appreciate the opportunity to speak with you today. So as you mentioned before, I've been around this industry, life sciences, chemical manufacturing, consumer products for quite a while. I've been on the vendor side of things, producing software, commercial software for R&D laboratories. I've been on the customer side as well. I worked at a pharmaceutical company, large pharmaceutical company, for about 10 years there. And last 10 years or so, 5-ish years now, I've been doing consulting work. So helping small companies and large companies with various strategic problems, how best to spend your money from an informatics perspective based on where you sort of are as a company and your R&D strategy, up through large digital transformation efforts as well. So I'm very pleased to be here today. And thank you very much for the invitation.
And like I said, haven't had an opportunity to speak with you on webinars. Those tend to be a little bit more passive. Now we get a chance to kind of chat back and forth, which I'm excited about. And thank you for making the trek down from beautiful Vermont. We're glad you get a little bit of warmer weather, which is Philadelphia in January. So obviously we're excited to hear more about how to bring digital transformation to the next level. Many companies are obviously thinking about this right now or are involved in one level or another with some, digital transformation. It's a big term. It encompasses a lot of stuff. And, for science-based businesses, as we know, regardless of, whatever their vision is of the future or what products that they're trying to bring to market, digital transformation is going to be a part of it, one way or the other. And with digital transformation, and putting data in the cloud or what have you, data integrity obviously is going to come into play, right? So let's kick it off with this question. How can organizations ensure data integrity and compliance is preserved during what is a highly disruptive process of digital transformation?
Thanks. I think from my perspective, at least in the digital transformation realm, as you say, it's a very, very popular, topic of today, last 5 years or so, these programs. I look at the aspects of data integrity with it as not an opportunity to preserve data integrity, but actually improve data integrity as part of these efforts. Digital transformation, in its purest sense of the word, is transformative, if you believe the words. And in that sense, it's going to be disruptive. There's pretty much no way around that. It is generally disruptive more in a cultural sense from an R&D organization perspective than it is in any technical sense. And in fact, the biggest challenges of digital transformation programs are cultural in nature. It's changing the way that people think and work together as groups and units and departments and teams, et cetera. And really the aspects of data integrity as applied to it, the core fundamentals of what we consider data integrity, ALCOA or FAIR types of acronyms, aren't in conflict with digital transformation, in fact, at all. They're necessary but not sufficient in some ways. So part of the effort is really understanding that as you go through this journey of digital transformation, maintaining and enhancing your data integrity along the way is important, not just from a regulatory perspective or all the reasons that we're used to talking about data integrity, but in fact from a scientific perspective. And guarding the provenance of your data, guarding the completeness and accuracy of your data and moving forward is actually a critical part of a successful digital transformation exercise. So it's not about, to me, it's not about just preserving data integrity. It's actually an opportunity to improve your data integrity in scientifically meaningful ways, along with, of course, maintaining the regulatory aspects of it.
Well, do you find, so that's an interesting thing. You said a couple of points that maybe I wanted to drill down on. Interdepartments. Maybe you might have departments that historically don't talk to each other much, but once they start to go through this process, the transformation process, do they have to start kind of bumping up against each other, and then they have to figure out how one person's data interacts with another person's data? Maybe they didn't have to think about that before?
That's very much the most fundamental part of digital transformation. Guiding the principles of a digital transformation is really looking at how is the data actually being used. We're used to building our systems, and we're used to approaching R&D informatics from the perspective of how we create data and building our systems around capturing that data, which again is an important, very important part of things, certainly to data integrity aspects, but it's not sufficient from a transformative point of view. To truly transform, you actually have to look at who's using your data. So it's not about you, the creator of the data, the designer of the experiment, the guy at the bench executing, capturing the results, doing all that, which is the classic way we look at informatics in an R&D setting. It's really getting out of your shoes, getting out of your box, and going down the hall, finding out who's actually looking at your experiments and what are they looking at and what are they actually using. And that's part of the cultural aspect of these transforms, is really coming out of the mindset of capturing all of the data, that you produce day in and day out, and really starting to focus on who's using it for what purpose, and how can we make that consumption of the data actually better and improve the integrity. From the point of view of the person consuming the data, what aspects of the data might they need or want to better understand it, to better believe that it's complete and accurate and relevant to the problem set that they're actually looking at.
Great. That's awesome insights. Taking that a step further, you kind of start to think about what does this lab of the future look like? And obviously people are trying to get to that. It's a popular buzzword. Digitally connected lab, all these terms associated with digital transformation. So when you delve a little bit further into it, it generally means that the lab will be off paper. Laboratory systems will no longer be siloed, as well as their departments. They'll be digitally connected to each other, and the tasks that will be considered manual have the potential, to be automated. So that's the common perception of what the end result of digital transformation is. So would you agree, however, that throughout the course of planning a digital transformation, that the opportunity to wipe the slate clean, so to speak, and completely reinvent the way your lab operates? I mean, is that a fair thing?
Yeah, absolutely. It's certainly an opportunity if you truly, again, buy into the transformation part of digital transformation, right? It is definitely an opportunity to sort of put aside some of the assumptions, that have existed in the way that your environments are created, the way that you're managing your data, the way you're communicating the data, the way your teams are working together across functions, across disciplines, and look at it basically with a clean slate, right? In that sense, and I think that's the type of thing that is really driving people's interest in a transform. I mean, the way we've been doing things, it's not that it hasn't been successful, of course, as an industry, but it clearly, the general thought is that it could clearly be better. So let's rethink exactly how we manage the process from discovery to product, right? How we manage that process of taking something that is a new idea or a new compound or a new therapeutic of some form in the pharmaceutical industry, and actually making it all the way out to the patient itself. Like, how do we relook at that process in ways, still maintaining critical regulatory compliance aspects, of course, in all that, but how do we as scientists rethink how we work with each other? That's the critical part of the digital transformation.
That's a great point. Very topical. Are there any particularly effective ways that people could reimagine workflows? So an example might be integrate compliance with overall R&D data flow during a digital transformation program.
Right. So I think, again, looking holistically at the things I think is part of the key. One thing that's challenging in speaking about this is every company is a little different. And I mentioned before the importance of culture and the impact of culture, really in the overall digital transformation programs. Because of the importance of culture in this, there's not like a handbook. You can't go buy a handbook and say, do the following, follow the checklist, and you will be digitally transformed. So there's a lot of cultural aspects to it that you really have to pay attention to.
Can't just do a YouTube video on it and figure that out.
Yeah, can't Google it and be happy with what you're going to find out. Or find meaningful, practical things, certainly, right? And I guess that's one of the things that's really key to me in sort of what I do is the practical things. I want to actually see things change, right, as a result of this. Not transformation in name, but transformation in terms of what happens in the actual process itself. And so, it is that opportunity to look holistically, step out of the position of just improving what you're doing that moment in that lab, right? Bringing in a system to just automate a specific set of experiments or do better data capture on that specific set of experiments, but really look at it in the bigger picture, point of view. And again, from a transformation point of view, that holistic viewpoint is really the best place to be. That means, again, back to culture, that doing this requires high-level support, right? You're going to fundamentally be looking at the relationships between organizations and teams, right, in an R&D setting. And you can't do that entirely sort of bottoms up from the point of view of the individual scientists. You really also have to have strong management support to look at these questions, because it does raise tough questions about, how companies are actually performing the work.
Definitely. And of course, when you get into these discussions about large-scale transformation of how companies operate, on one side of the fence, you've got culture, you've got processes, and then, of course, on the other side of the fence, you've got technology, which can oftentimes be one of the drivers. And there's no discussion of digital transformation in life sciences without the discussion of data science, artificial intelligence, machine learning. Where do these pieces fit in? Are people just chasing the next buzzword of tech, or are they appropriately incorporating these new technologies into their workflows? Do they not fully understand them yet? What are some ways that they can incorporate these in intelligent ways they can actually use them without just going out and buying technology that might sit on the shelf?
Yeah, that's a very fair question. There certainly is an amount of buzzword happiness, right, in this. The phrase digital transformation itself is, in fact, a buzzword. And, AI, ML, and, unsupervised learning and all these things, the industry has been through this many, many times. I've been through this over the decades I've been working in this industry, the latest set of buzzwords, right, and how that's going to radically change things. And so there is an element of that. But I think the other thing that's different right now, and every time frame, every change essentially that we've gone through in the environment, in the R&D world, has taken advantage of certain aspects of technology, right, that have clearly evolved over time. And it's fair to say that from a technical point of view, the current technologies around data capture, data storage, and use of data, whether that be from sort of a direct point of view, tools like visualization and all that, or from the point of view of machine point of view, using it for AI and ML and doing unsupervised learning, and that technology has advanced remarkably. Every day our phones, we're faced with image recognition, that's far beyond what we would have expected, even 10 years ago. Walk into a store, hold your phone up to something, and you can get immediate feedback about where you can buy that item cheaper, right, within your locality or order it online, et cetera. So there is a practical aspect of being able to use those technologies, right, in an R&D environment, absolutely, and that's a reasonable goal for digital transformation programs, but to use those technologies effectively, there's a number of steps that you actually have to go through in order to be able to get to that point as well. And I think, my concern is sometimes we overlook the prerequisites to getting to that point, to being able to use unsupervised learning, for example, and those types of things on our data. The data itself has to be ready to be used in that particular way. And the big part of digital transformation is all the homework that's actually required to get data into a format, into a structure, not so much a technical format, but actually a structure and contextualize in the right kind of way that people can use it beyond the person who created the data. That's one of the bigger challenges. As a scientist working in a laboratory, designing an experiment, executing an experiment, you're holding in your head a tremendous amount of context for why you did the experiment and how to interpret the results that have actually come out of that. And we are still working through the process of how to actually capture that kind of context and communicate that to other people that can then use our data. And that's a critical part of the cultural aspect that I was talking about before. That when I talked about the idea of like going to find people who are trying to use your data and ask them what they're trying to do with it and what's their frustration points with it and were they able to use it successfully. That's the kind of feedback loop that can help you understand the missing pieces of context, right, that need to be augmented and captured for that data to be useful. And doing that person to person is as effective as a tool, as effective as a way to being able to treat that data with machine technologies as well. So the same kinds of gaps that a machine is going to find in being able to properly interpret the data to use it in an AI ML kind of sense, people are going to find those same gaps for you. So, this whole process of digital transformation can be viewed people to people, but clearly can also be viewed as making data more useful for machines as well. I think the two are inherently linked to each other that way.
I guess it's like the age-old thing, like, you can have a conversation with someone and understand the context, but if they send you a text and you don't have context behind the little sentence of that, you can misconstrue it and you don't know what it means, or you can take things out of context. So context is certainly important. So that cultural aspect, it plays a big role. So tech, all the data, all the new methods for processing data, all the new advanced learning technologies, et cetera. How do these practically play a role in data integrity? As we kind of get to the end of this digital transformation, of course, you've got the cultural aspect of it. You've got the executive sponsorship has to say, okay, we're going to do this. The interdepartmental, connections that, have to be made that maybe didn't exist before. All these different pieces leading up to it, the capture of good data so that you can feed these systems. Once these systems are doing their thing, then do you have some experience or some thoughts on how that helps with the compliance and the data integrity piece?
I think what's important here is there's two different ways to look at data integrity, at least two different ways to look at data integrity, but two main ways I try to think about it. So one is from the compliance point of view, right? And so what you need from a regulator's point of view to ensure the integrity of your data, the meaningfulness of it, there's a number of technical aspects, if you will, that need to be incorporated into your thinking and into your programs, basically. So you need to make sure that you're appropriately tracking the provenance of your data, right? That you have made appropriate allocations in your system sense, right? For where did this data come from? Where did it go? How do we know it is the same that it was when it was actually created and came off the original instrument, et cetera. So there's a number of very technical things that become requirements, effectively, in the program itself as you decide what data flows you're actually going to use. And so that's one important aspect of data integrity. And that's more formulatic in some ways, right? You should be able at the end of that, be able to assert that type of data integrity, prove that type of data integrity by the way that you've constructed your systems and the relationships between the systems. The other type of data integrity is from a scientific point of view, right? So as a scientist, that's like, to me, that's another layer, right, on top of this. As a scientist, I want to know that the data hasn't been changed, that the data is complete, that it's accurate, all of the things that we would normally sort of check off against Alcoa Plus or other sorts of notions of data integrity. But in addition to that, I need those other pieces of context as a scientist for that type of definition of data integrity. So I truly think that these programs that we're embarking on now, this decade, if you will, of improvement on laboratory data management and the use of digital transformation is not just an opportunity to improve the regulatory type of data integrity, but also the scientific type of data integrity and make our data more useful to other scientists. That's always been a critical struggle in science. Scientists never like to throw away data, right? We keep everything, the ultimate pack rats from a data perspective, right? But to people other than the person who's created that data has always struggled to have usefulness, right? And I think that is approaching data integrity from that point of view, layering on top of the compliance and the regulatory definition of data integrity to reach for those types of goals is really the opportunity with these kinds of programs.
It's good stuff, and it's great to hear, a scientist talk about these type of projects because, that's one of the things that, has been a hallmark of Astrix is we hire scientists, and our scientists are the people who go in and work with customers to drive these projects forward. So people who've been on the bench and people who've done this, it's a unique thing with how Astrix deploys folks to help with these digital transformations. It's an exciting time, I think, for life science. There's a flurry of new technologies. There's a realization that you have to come off paper, and we've got to really use this data to drive forth these products into the market and make people, feel better, hopefully. So leave us off with a couple of thoughts on round us out, and then we'll wrap up.
Sure. I think just building on something there in your response that I was thinking about too, I think all too often we view digital transformation programs as technology projects, and that's not the true nature of this, right? I practice science vicariously, right? To be clear, I mean, I don't do science anymore. I was trained as a scientist, but now I get to apply basically sort of the technology of IT to science and be around the science essentially in that sort of sense, which is where I get a lot of my motivation and energy from. But the technology aspect of things is really, I don't know, it's at least at most secondary, maybe even tertiary, right? In these types of transformative programs, we all too often, I think, one of the traps I see people falling into around these programs is really viewing it as an opportunity to do very specific system-oriented kinds of things, and being too fixated on the I've got this cool technology, let me go find a problem that I can apply it to, right? Mm-hmm. And what I advocate in terms of the digital transformation side of things is really to look at it, like I said, from the scientist point of view, from the people point of view, really here. So it's not that systems and technology aren't important, and clearly at the end of the day, you're going to want to implement things, right? At the end of the day, it has to be realizable. There is a very important technology and aspect of it, choosing the right technology, making sure it's scalable, and all those kinds of things, performance, et cetera. But really the start and the driving forces in a digital transformation exercise are really about the scientist to scientist level of things. So I guess, one word of encouragement I would have to people is, don't just think of it as it's another system implementation. Pick your 3-letter acronym, ELN, LIMS, whatever, right? It's not another implementation of another system like that. It's not an upgrade of those systems. It's really got to be a whole way of thinking about things that's different from the way we've been doing things traditionally. So
great. It's always a great time to listen to you talk, Dave, and hear your thoughts on these things. As I said, it's an interesting and compelling time in life science with such a wave of technological innovation and pushing forward off of paper onto digital. So thank you for making a trip down. It's always great to work with you. Thank everybody for listening in and downloading the podcast today. Obviously, stay tuned as there are plenty more podcasts coming as part of the series in the future. Again, my name is Kevin Miller. We're with Astrix, and this was our Digital Transformation Podcast. Dave, thank you very much.
Thank you very much. Thanks everybody for listening. Hopefully you've got a few things to take away for thought material. That's my goal. So
absolutely. All right. Thanks everybody. Appreciate it.